Okay, this is just going to be a brief video, a short introduction on completing the square. Completing the square is one of the most difficult topics that we learn in Honors Algebra 2. And I really just want to go over the front page of this notes. You do not need to complete these problems. You actually won't be able to really complete these until we get to the back part of the notes. But you having watched the explanation for the front of these notes will definitely make the next class's lesson much easier. Okay, as you can see in the box here, I'm kind of keeping a tally here of all of the different techniques that we've been talking about for solving quadratic equations. We first talked about graphing, then factoring. Our most recent method was simply the square root property. And the deal with the square root property is when you are isolating whatever is being squared. So you're getting that part by itself, and then upon doing that, you would then take the square root of both sides. Okay, this method that we're going to be just barely touching on, and we're really just kind of setting the stage for the completing the square process. I'm not going to be walking you through how to complete the square, but this will really make completing the square, when we discuss it, so much easier that we've talked about this front page here. Okay, completing the square is definitely the most complex of all the techniques that we will be learning. In fact, one aspect of completing the square involves something that feels like the square root property. So I want to start with that first. In example 1, you can see, and if you recall, I had highlighted this here, for the square root property, you're supposed to get by itself. That's what isolate means. Isolate whatever is being squared. As you look at this example, you can see that the exponent right here, the 2 is right there. That means what's being squared is the x plus 3. So I want to make sure that the only thing that is on this left side is just the x plus 3, because that's what's being squared. Okay, once I've made sure that that is isolated, I am then going to take the square root of both sides. So I would take the square root of this side and the square root of that side. Now we know the way that it works when you take the square root of something is it should cancel out that exponent. So if I'm taking the square root of x plus 3 squared, I should just be left with x plus 3. Okay. Now, when you take the square root of 36, technically the answer is not just 6, but it is a positive 6 as well as a negative 6. So you're going to put a little plus or minus symbol in front of the x. And the goal here is to solve this equation. So we're ultimately wanting to get the x by itself. So what we would then do next here is we would move this 3 over to the other side of the equation. I would encourage you to put it in front of the plus or minus symbol. Okay, and then you really actually just want to go through this problem twice. You're going to say negative 3 plus 6. If I were to do that, I would get 3 as one answer. And then if I were to go back through a second time, negative 3 minus 6, I would get as my second answer negative 9. Okay, these are our two answers. We know that if we were to do this problem by, say, the graphing method, these are the two places where that parabola would be crossing the x-axis. Okay. I did this middle one here for you. I want you to really pay close attention to this third example, because remember, when we're doing the square root property, again, we have to make sure that the only thing that we have on the left side of the equation is just whatever is being squared. Now look at where that exponent is. You'll notice this exponent is only on the x minus 5. This extra 2 that's in front here, that has nothing to do with that exponent. So before you get ahead of yourself and start taking the square root of both sides, you first need to get rid of that 2 that's in front. Okay, so I'm going to divide both sides by 2 so that I in fact am just isolating what is on the left side here. Okay, once I've isolated what's being squared, it is now safe for me to go ahead and take the square root of both sides. The square root of x minus 5 squared is simply x minus 5. Now in this example, you'll notice I'm not taking the square root of a perfect square like I was back here when we did the square root of 36, or in this example right here, so the square root of 25. If it's not a perfect square, do not type that into your calculator and write the decimal down. Okay, you're going to leave the square root symbol over top of the 27 and go ahead and put a plus or minus in front. Okay, anytime you're doing the square root of a number, you put a plus or minus in front of that. Okay, now we didn't do that over here because there was a variable here. Okay, now I do want to get this x by itself though. So I'm going to add 5 Okay, and it's always a good idea to kind of squeeze. You notice I left some space here. Kind of when you bring the 5 over, it's a good idea to put that number you're bringing over in front of the plus or minus. Okay, now we're going to leave our answers in what's called their exact form, which means we're not rounding them. If you type in 5 plus the square root of 27, because 27 is not a perfect square, you will have no choice but to round that answer and write it as a decimal. Okay, it will not switch it back into a fraction. They call this an irrational number when the decimal cannot be switched back into a fraction. So actually, we're just going to leave our answers like this when the number underneath the radical is not a perfect square. Okay? All right, so in the next example, it says again, solve by using the square root property. But you'll notice, as we look at this, I do have something squared, but the issue is I also have another term that has an x in it that poses a little bit of a problem. So they gave you a little hint. It says here, you need to factor the left side of the equation first, okay? Now, we're not bringing everything to one side. It said just factor only the left side of these equations, okay? So I'm going to leave that 20 over there. Whoops. I'm going to leave that 20 over there. I'm going to leave this 32 over there. I'm going to factor. Now, we had talked about factoring methods. We said when it's a trinomial, if the lead coefficient is a 1, which is the case in both of these, we do not need to draw the 4 blank lines, but instead, we can just go ahead and go right to our parentheses, and we'll set this other one too here. Okay, now I know this feels a little weird because we always had a 0 on this side before, but this is just saying, look, just factor the left side first, okay? We are definitely going somewhere with this, and you'll see how this will all kind of pull together, particularly the next day when we look at how to complete the square. All right, so A times C on this is 16, B is 8. I'm looking for two numbers. They need to multiply to be 16, add to be 8. Those two numbers would be 4 and 4. So I'm going to put plus 4 here, plus 4 here. Okay, now remember, this was asking us to do the square root property. Well, if we're doing the square root property, something should look like it's being squared. Well, if you look at what we have here, we have the exact same factor showing up twice. This is kind of duplicated. So instead of me writing them out twice, I technically could write it and just say, well, I have 2 of those x plus 4s. Okay, now once I have it written like this looks really similar to how these original problems looked up here in the 3 examples that we just looked at. Okay, we're supposed to make sure that we're isolating what's being squared. I think that's the only thing on the left side. So I'm going to go ahead and proceed by taking the square root of both sides of the equation. That gets rid of the exponent on the left. 20 is not a perfect square, so I'm going to leave it underneath the square root symbol, put a plus or minus in front. I'm going to squeeze that -4 when I bring it over to the right side. I'm going to put it right in front of the plus or minus. Okay, that's as far as I can go with this. If I were to type this into the calculator, I'd have no choice but to round my answer, and I do not want you rounding these answers, please. Okay? All right, let's try another one here. A times C on this one. A times C is 9. B is 6. My two numbers that are going to multiply to be 9 and add to be 6 are 3 and 3. Okay. You'll notice that a very similar situation happens in this problem that happened in the other one. We have a duplicate factor, 2 of the x plus 3 quantities there. So I'm going to go ahead and write it together so it looks like a quantity squared. I'm going to take the square root of both sides here. Okay, that gives me x plus 3. Again, 32 is not a perfect square, so I'm just going to put a plus or minus in front of it. This is as far as I can go. Okay. All right, so let's see how this kind of pulls in here. What a perfect square trinomial is it's a trinomial that when you factor it, it results in a binomial squared. For example, this x squared plus 8x plus 16 factored into a binomial squared, x plus 4 squared. This x squared minus 6x plus 9 also factored into like a duplicate factor. That's what we mean when we say this was a perfect square trinomial. Okay, so here's what we're after. We want to find in example 3, what should be the number here for C that would make this a perfect square trinomial. And once we fill that number in, we're then going to show how this would look factored. Now, you'll notice up here, I have kind of what the formula or shortcut is here for how perfect square trinomials would look factored. What the C value is, okay, and I'm going to have you label this, that this represents the C value. The C value in all perfect square trinomials is always whatever your B value was, divided by 2, and then squared. Okay? Anytime that is your C value, you are looking at a perfect square trinomial. Now let's look back here. Let's see if that's true. Our C value on this one was a 16. So this is saying if I take the B value, which is 8, if I divide that by 2, make it a 4, and then I square that 4, I get a 16. And look, 16 is exactly what the C value was. So if I'm supposed to fill in the C value for this, I'm going to say, all right, well, first of all, the B value is a 16. If I divide that by 2, I get 8. And if I square the 8, I get a 64. So we're saying the C value should be a 64 in order for me to make this a perfect square trinomial. Now, if that's actually a perfect square trinomial, when I factor it, it should factor into a duplicate factor, just like up here with our X puzzles. See how we got the exact same number, 4 and 4 and 3 and 3? Okay, if we were to do that, two numbers that multiply to be 64 and add to be 16, that's 8 and 8. So we fill in, it would be X plus 8 times X plus 8, or we could just write it like this. Okay. Now, there is a shortcut to this. I'll draw your attention to the right side here. This is that duplicate factor squared. Okay, instead of me making an X puzzle, this number that is the duplicate factor is whatever your B value, the B value, divided by 2. Okay, you'll notice that was 8. Look at what we filled in here, 8. Okay, so whatever your B divided by 2 is, that is the duplicate factor. Okay, if you know that, then we don't have to make X puzzles for these kinds of problems. So let's try one last one here, and this will set the stage up so that when we start talking about completing the square together, it'll be much easier that we've discussed this already. Okay, so first of all, we're trying to figure out what is the C value that would make this a perfect square trinomial. So I'm going to say, well, the B value is negative 14. If I divided that by 2, that would be 7. I'm sorry, negative 7. If I squared negative 7, that would be 49. So that means the C value should be a 49. Now, that's a perfect square trinomial, so it means it's going to factor into a duplicate factor. I'm not going to make an X puzzle for this. I'm just going to look over here and say, what did we say B divided by 2 was? Oh yeah, minus 7. So that means if I made an X puzzle, my two numbers would be negative 7 and negative 7. So I'm just going to go ahead and fill that in here. Right there is where I'm putting the B divided by 2 value. Okay. All right, that's where we're going to stop. You don't need to work on any problems here that are associated with this.